Applied Sciences, December 2007. I just feel this is actually a case study that has been conducted by the Civil Engineering Department of IIT Roorkee, and the name of the journal is Site Suitability Analysis for Urban Development using GIS. So let's start through the abstract. So let us see what the abstract says. The future success of economic growth policy depends on a lot of infrastructure development. So it is universally established that remote sensing and GIS tools play a major role in various infrastructure development. Several decisions taken by different planning agencies require spatial analysis of maps involving many parameters. The GIS-based maps provide the most important source for spatial analysis. Remote sensing data provide latest and accurate maps when used in GIS environment. So basically, this GIS-based maps will provide us the most important sources for spatial analysis. And with that, we include. Excuse me, I have pause to be taken. So as the migration of population from villages to cities happen, there is a necessity to improve the amenities in the city. And also, there is also a necessity to find out the potential areas for residential, commercial, and industrial buildings. And in the introduction, they are talking about several references that they have taken from other journals in which there some predictions were done on the population division with within a span of some years. So that they have highlighted that almost 38% of Earth's population is living in urban areas, and by then 2025, the population is expected to rise to 61%. That means by 2025, the total population, 61% of the total population would be residing in urban areas. So this implies that 5 million people out of a total world population of 8 billion will be living in urban areas. In 2025, we are expecting a population of 8 billion all over the world. Out of that, 5 billion people will be living in urban areas. That might be due to the better living standards and better employment opportunities that urban areas are providing them. So the rapid increase in urban population and the transforming urban economy lead to never increasing load on the urban environment in terms of urban infrastructure of cities, creating many problems such as unplanned sprawl, inadequate housing facilities, traffic congestion, insufficient drainage, sewerage facilities, and lack of other amenities. So we have seen from our own eyes that how unplanned towns have become a burden for both the residents and also the people who pass through the town. So we have several towns and small junctions all across our state, and we can see how unplanned development have affected the total well-being and of the people living around there. So ഇപ്പോൾ ഇത് പറയുന്നത് എന്താ വെച്ചാൽ ഒരു പ്ലാൻഡ് അർബനൈസേഷന് വേണ്ടി GIS എങ്ങനെ യൂസ് ചെയ്യാം എന്നതാണ് ഈ സ്റ്റഡി ജേർണലിൽ കൊണ്ട് അർത്ഥാക്കുന്നത്. In the introduction, they have also given some references from some other journals. So just read through that and understand what are all those. So from introduction, they have understood what is the problem and how what is the problem. They have identified the problem from the journals that they had referred, and from that they have formulated a methodology. And let's see what are the materials and methods that they have used for the size suitability analysis in Roorkee. So we'll just discuss about the study area that they have mentioned here. The study areas was in the Roorkee. It is actually a very small town of moderate size, the district of Haridwar. So it's in Uttaranchal state and is located on the banks of Upper Ganga Canal, which takes off at Haridwar. So it's about 30 kilometers south of the Shivalik range of the mighty Himalayas, about 170 kilometers to the north of Delhi, and situated in Amritsar, Howrah main railway line. So all of these are basic things about the study area that they have considered for the study. And they have also mentioned about the various facilities that are available in Roorkee and how they are linked to other railway lines and other transportation facilities. The location is also given with the latitude, longitude, and the mean sea level of the Roorkee town is also the height also given. So why Roorkee? Why they have selected Roorkee is that you can see they both these authors are from the Department of Civil Engineering, IIT Roorkee, and so they have chosen the nearest town to their institute. That's why Roorkee was chosen. So depending upon this study, you can choose any town and we can apply the same methodology. So let's see what was the methodology by this team. So the Survey of India topographical map, the number given, and aerial photographs and satellite data were registered using polygonic projection system. Satellite images was digitally enhanced in order to extract maximum information. So we have learned in the first module how we can, in the second module, I guess, how we can transform digital images into something from where we can get suitable information. So they've given different attribute layers such as urban area, agriculture area, forest area, and rivers are generated by digitalizing a GeoMedia Professional. That's actually a software available. So these layers were exported to GeoMedia Grid to find out the changes and to prepare change detection maps. For suitability analysis, different parameters like land use, roads, ground, water availability, and water bodies are considered and categorized with various attribute layers by using GeoMedia Grid tool. So what they have done is like they have categorized all these with different layers, where each layer will correspond to either the land use pattern or the road network or groundwater availability and other water bodies available. So all these things will be given in different layers, and they will merge all these layers, and they'll find out which area is more suitable for uh, industrialization. So it's actually based on in urban development. So they've also studied the expansion trend that has happened during the term 1967-2003. So we need to find out the overall expansion of Rocky Town. Layers of various themes for years 1967-2003 has been intersected with each other. So they have done is like uh, layers of various themes. So each layer will have different theme. As I've said earlier, the one theme might be the land use pattern. The other theme might be the water bodies available, and next thing will be the geographical projection. So all these things will be taken, and what they do is like they will intersect everything, and they will find out how the land use pattern have changed over the years from 1967 to 2003. So the change of one land use to another land use has been determined. The map represents the trend of land use changes shown in figure 2, and the area extent is given in table 1. So there is actually, they were seen figure 2 and figure 3. So you can see how the land use areas have been represented, though the figure is not as clear as we expect. You can see how the land use pattern have changed over the years. So yeah, the figure is not so clear. Still, I can. So this is the methodology. This is the flowchart of the methodology that they have developed. First, what they have done is like they have taken the maps from different satellite images over the years, and they have registered them, and they have digitalized them. Like in spatial and spatial data was created, and they created several themes layer with several layers with different themes like land use, groundwater, roads, water bodies, etc. So this is the thing that you need to write down in your examination if something is asked related to the site suitability analysis using GIS. So you can take help from this uh, flowchart, where it says that the first maps are prepared, and they are then they are registered, or then they are manipulated using some softwares, and they will be divided into several uh, themes like land use, groundwater, roads, water bodies, etc. Then they will be rasterized, and then all these things will be intersected to find out uh, find out the suitability of each area of the total area considered. So you can see how they are rasterized into land use. Roads will be again divided to accessibility, groundwater, uh, DEM. We have discussed about that. Digital elevation modeling, water bodies, and how flood hazards, how much flood hazard is there due to the presence of these water bodies. Everything will be taken as different things, and they will be analyzed together, and they will find out how the urban growth pattern and site suitability map can be prepared. So this is the strategy or the methodology that they have done, and you can refer this same methodology. So in the table 1, they have also summarized how the land use pattern have changed over the years, or the overall expansion of Rocky Town from 1967 to 2003. And you can see how the area have changed all these years. So if you see the agricultural land was in area in 1967 was what 10.31 square kilometers of agricultural land, and how they have changed in 2003. And similarly for all those things, for thin vegetation, vacant water bodies, etc., how all these things have changed. So this if you want to find out the area of in 1967, let us refer from top to bottom, and in 2003 area, you'll have to refer from left to right. So you can see how the urban agriculture have changed. Overall expansion, it has expanded like 10.31 kilometers square, and how the agricultural land we can have become is like 0.05 meter square is a total expansion happened. And in urban thin vegetation, urban vacant areas, water bodies, how they have changed all the years. So all those things they have summarized using the table. And you can see the figure also. What they have done here is like they have uh, intersected the maps that they have drawn using various references in 1967 and 2003, and they have understood how the land use pattern have changed over the years. So the selection of suitable sites is based upon a specific set of local criteria. The characteristics of site example the present land use, slopes, water availability, distance to employment, development cost, geology, geomorphology, etc. Suitability for a specific land use type. To assess the overall suitability, a scoring and weighting system is applied to various aspects of suitability. So what they have done is like they have quantitatively analyzed the site suitability. Here they have given a weightage for each of the aspects. Suppose some employment aspects might be having a higher weightage than uh, water body presence of water bodies. So different aspects will have different weightage. So since it is related to the urban development, here employment opportunities are more important than what we see the land available for agriculture. So hence it will have a higher weightage than that of land available for agriculture. The site suitability analysis is a process of understanding existing site qualities and factors which will determine the location of a particular activity. The purpose of selecting potential areas for residential development depends upon the relationship of different factors like location, available sites, extent of area, accessibility, etc., and site location factors like slope, soil, etc. So all these factors will come into picture when we do a site analysis. So we will find the relationship between the different factors like location, extent of area, accessibility, and also with the type of soil, the slope, that a particular area, etc. So the analysis may also determine how those factors will fit into the design process to evaluate the site suitability. So for any suitability analysis, appropriate base data is required. Base data means what they try to tell us is the satellite data or air photos or topographic maps, all those thematic maps and the field data that are available. That's the base data that they are referring to. The different land qualities which can be considered for suitability modeling are present. The land use of land cover slope, proximity of transportation network, flood hazard, groundwater condition, etc. The characteristic of a site, that means the present land use, water availability, road accessibility, flood hazard, etc., influences suitability for further urban development. To assess the overall suitability, a scoring and weighing system is applied to the various aspects of suitability that we have discussed a few moments ago. The suitable sites are found out by adding all layers which are affecting the site suitability. That means they will create, they will categorize each layer into different site aspect. It means one layer might be regarding the employment opportunities, other might be regarding the soil characteristics, other might be the availability of transportation facilities, etc. So what they do is like they will add all these layers together and they will understand which area will be most suitable for uh, urban development. The selection of different parameters for suitability. Then we need to understand what are the parameters that will affect the site suitability. So the following parameters have been considered for the suitability analysis. Let us see what are they. First is the existing land use, flood hazard, groundwater, road accessibility. So if we come to existing land use, so land use or land cover map is a comprehensive expression of land use or land cover classification. This map has been prepared by using IRS span data and shown in figure 3. Let us see what is figure 3. See, this is actually the existing land use. So if you see here, some might be existing buildings, might be the vegetation. There are some water bodies. there are some vacant areas. So this is actually the land use pattern, how the land is being used over the years. So this map is also actually prepared. Then next is like flood hazard. So major rivers have been displaced from the topographical map to delineate the flood hazard prone areas. Various buffer zones have been created by taking different distance values from both sides of the river banks, as shown in figure 4. So let us see what is meant by figure 4. What they have done is like the area lying along the banks of the river, they have divided into zones. Just a second. Sorry about that. So in the figure 4, what we can see is like how they have categorized all these flood hazard zones. So those areas lying close to the river, they have categorized in zone 1, and relatively as we move away from the river uh, river bank, these areas will be differently categorized. So this is actually they have prepared how the flood hazard map. And next map, what they have prepared is the road accessibility map. So the study was done in order to find out the accessibility of the region. So major roads which are connecting to different areas have been disguised the survey of India topographical map of a Roorkee town, and buffer zones has been created by taking different distances from the road to generate road accessibility map. So for example, if the main road is uh, 5 kilometers from a particular point, we'll give a particular weightage for that particular uh, place. But if there is some other place where the main roads are available at 1 kilometer, within 1 kilometer distance, a higher weightage will be given to that place. So similarly, those factors affecting that, like existing land use, flood hazard, road accessibility, groundwater, etc. So different weightages will be given to all these different places that are being considered for urban development. So some buffer zones will be created, and hence weightage will be given for them. And similarly, and next is map prepared was groundwater table. So groundwater is an important resource for urban existence and growth. In Roorkee town, growing population and desire for good quality of life is placing greater demand on good water resource of Roorkee town. The groundwater map of the study area has been prepared by using groundwater contour map. Figure 6 shows groundwater categories. It is covered by different categories, also given table 5. So we'll see what are all these table 4 and table 5. Figure 5 means road accessibility. You can see there are some major roads, and they have categorized all these things in different areas. So those areas which are lying along the roads, which are very close to the main roads, they will be categorized as very good. And if they are at some distance, it will be categorized as good. So similarly, as we move away from the roads, the weightage of the place will decrease. So what the next they have done is regarding there is some table they have mentioned. What they have done here is like they have categorized how the land use pattern is over the years. So what's the percentage of area that has been kept as urban, in what percentage area there is agriculture happening, what percentage of area there are water bodies available. All these things they have tabulated, and they have formed and they have expressed in terms of percentage. Similarly, they have categorized uh, flood hazard zones, and like high, medium, low, and nil. They have measured how much area is under high flood hazard zone, similarly medium, low, and nil. And for road accessibility, those areas having a very good road accessibility. So you can see how the buffer zone is defined here. If a place is within 200 meters from the main district road, it will be categorized as very good road accessible area. And if that particular area is between 200 to 500 meters away from the major district road, it will be categorized as a good uh, area with good road accessibility. And similarly, as we move away from the road, the category will change from very good to very poor. And they have also measured how the area of land that comes under each category. And similarly, groundwater categories. And with that, what they have done is like they have given some scores. They have considered all the scores. That is, this paragraph says, as this paragraph says, for suitability analysis, it is necessary to give some score to each of the category as per the suitability for urban development, since each category will not have the same weightage or usefulness for urban development. So similarly, that was I was actually saying before. See this line. Uh, each category will be given different scores and weightages, since each category will not have the same weightage or usefulness for urban development. As we earlier said, the presence of water bodies might not have the same weightage as the availability of nearby road networks as in urban development. So obviously, the areas with good road networks will have more weightage than those areas having good groundwater availability. So depending upon the land use that we intend to provide, the rankings of all these things will change accordingly. So this is the thing what we are discussing about, and with that we have tabulated the suitability scoring for each type of land use. You can see how there are some suitable scoring from like 10, 7, 4, etc. And for road accessibility, there is scoring given as 10 for all those areas which lie within 200 meters from the road. And flood hazard, uh, similarly, you can see the score is 0 for those areas which lie very close to the flood hazard zones. That is within 100 meters from the flood hazard zone. The score given will be 0 for that. And for groundwater, very good places with very good accessibility to groundwater, they will get a score of 10. And similarly, depending upon that. So if you notice here, you can see areas with very poor availability of groundwater gets a score of 2, while uh, areas with poor, very high flood hazardous areas will get a score of 0. That means even though an area, if we compare two areas in which one area the availability of groundwater is very poor, it gets 2 points. And at the same time, in another area, when if it is subjected to flood hazard, it gets 0 points. Understand? So here what happens is like for urban development, groundwater accessibility is of less importance than flood hazard. So for urban development, flood hazard is taken more seriously than the availability of groundwater. So likewise, each different suitability has different scores. So that's what I'm trying to say. So next important parameter concerned is the flood hazard. Flood hazard as a safety measure can be done to avoid damages. Also, urban development is higher at the vicinity of the river and canal. So following the flood, next parameter is accessibility to particular vacant sites. So distance to the main roads and other roads from the sites on the other hand may not affect strongly. So but large distance may involve some extra cost and increase in travel time, and also the development purpose. Accessibility is another important requirement. So if you read this paragraph, you can summarize what all things I have said earlier. How this weightage is given for different categories or different suitability things. So moreover, new road might be required to change the situation in those situations where there are some vacant sites and we are shifting people to that sites, etc. So the weighting system in this case is designed to allow a maximum score of 550. The 4 score maps have been added while applying the following weighting system. So for land use, the uh, weightage given is 35. For flood hazard, the weightage given is 9. For accessibility of roads, the weightage given is 7. For the availability of groundwater, the weightage given is 5. So you can see which has more weightage. Obviously, the land use has more weightage. So it will have a higher advantage. It will have obviously have an advantage over those areas who has higher availability of groundwater. But if that particular area is not suitable for the development or land use of an urban environment, then the scores will be very less for that. So here what they see is like, even though for urban development groundwater is not available, uh, that may not be a great problem, but the main thing that they're looking for is actually the land use pattern. So next is like a suitability map has been finally prepared by applying the above scores using a recording tool of GeoMedia and Grid software. The final output is a raster layer having particular suitability score, which is based on following relationship. So they have defined a relationship related to um, different land use pattern. So yeah, they will take the land use score and they will multiply it by its weightage, which is just 35, as we have discussed in the above paragraph. And they will consider flood hazard and will multiply with its weightage, which is 9, and road accessibility will be multiplied to 7, groundwater will be multiplied into 5. So each thing will have different scores and weightages, so all these things will be multiplied accordingly. So similarly, they will arrive at a final suitability score out of 550. You can see how they have finally come to the map they have as shown in the figure number 7, in which they have given a total score of something out of 550, and they have classified all these areas as highly suitable, suitable, moderate, less suitable, and suitable. So each will have different scores, and they have defined how much area is available for all these things. For highly suitable area, it's just 155 square kilometers of area is categorized as highly suitable for urban development, and unsuitable areas is categorized as 36.4. You can see how all these things they have done, and they will compare all these things with the latest thing. So 1967 map will be compared with 2003 map, and then hence we can find out how the land use pattern have changed over the years. So with the discussion, you can say that it is actually the comparison between 1967 and 2003 land use pattern maps. I hope you have understood what we have discussed as of now. So this is the thing which you need to write when a question is asked in your examination in this point of view. Um, Sometimes you can expect questions like this: how a science suitability analysis for development is done with the help of GIS. So this is the answer. So we have to start from the beginning. You can say you should say that different maps have been taken. Different maps need to be taken from different authorities, like land use maps, like topographical maps, um, groundwater potential zone maps, agriculture maps. All those things will be taken, and they will be compared, and each location will be given a specific weightage with respect to the availability of resources, whether it will be best suited for that particular land use, or it has a good accessibility of roads or railway or transport, any other transportation facilities, and also how the groundwater is available or not. Depending upon that, each uh, place will be given a particular score, and they will be multiplied by the weightage given. So here what we can see is like, we are talking here about the urban development, hence that's what the reason why the land use got the maximum weightage of 35, while groundwater got a very less weightage of 5. But if we are talking about the agricultural land use, here we were talking about the urban land use, and if we want to consider the agricultural land use, obviously you need to you need to understand that groundwater will get a higher weightage than land use and any other thing. So even accessibility will have a lesser weightage than groundwater. So because groundwater will be the main thing which is going to affect the agriculture. So depending upon the different land use patterns, all these things will have different weightages. So this is the thing you need to write in examination, and each thing will be multiplied. Each suitability criteria will be multiplied by its corresponding weightage, and a total score will be given to them. And finally, a map will be drawn in which it will be categorized into different things like highly suitable, moderately suitable to less suitable, all those things. So this is a way you need to answer to this kind of questions. Whatever the question may be related to the site suitable analysis of residential area or industrial area or any other thing, you can change the things which is happening depending upon it. So this is the way you need to answer to all these questions. So with this, I'm concluding today's class, and I'll post this journal in our Google Classroom. So please do refer and tell your friends to refer the journal that has been it will be posted in our Google Classroom soon. So thank you all. You may leave the class now.
Thank you, sir.
Okay.